Welcome to EDU World Space.
This is chapter 21, problem number 34. We are given a square, and on each corner of the square we have a point charge. So we have two kinds of point charges actually. Q1, negative 38.6 microcoulomb. And I'm going to call the other one, well, Q2 equals Q3 equals Q4 equals to a Q. That is given to us as negative 27 microcoulombs. So let's place Q1 here for instance. The figure is not given to us in the problem, so any solution would do. Q2 again equals Q, Q3 here equals Q, Q4 equals Q, right? That equals to negative 27 microcoulombs. This is a square, and the length of one side is given to us as, well, 52.5 centimeters. 52.5 centimeters, which means it's 0.525 meters, right? And we're asked to calculate the net electric field at the center of this square. Now, I'm going to show you a shortcut. So if you look at diagonally, right? I mean, each charge is going to generate its own electric field at the center of this square, and we are going to end up adding 4 contributions from each charge at the center in order to calculate the net electric field. However, let me show you something. Diagonally, the diagonal distance here, right? This distance is the same as this distance here. So if we just divide this square into 4, then this portion would be L over 2, correct? This height will be L over 2. This is L over 2. So we have hypotenuse here, right? So then this length would be L over 2 times square root of 2. Anyhow, this distance from Q2 to center is the same as the distance from Q3 to the center of the square, right? So then if we look at the direction of the electric fields generated by these two charges, since Q2 and Q3 both are negative charges, the direction of the field at the center point, let's say for Q2, since it's a negative charge, it's going to be towards itself, right? So this is the field generated by, let's call it E2, generated by Q2. And then if we look at Q3, the field generated by Q3 at the center, since Q3 is also negative and it's the same amount as Q2, it's going to be towards itself, Q3. So then this is E3. So when you look at the magnitudes of E2 and E3, E2 actually is going to turn out to be equal to E3. That equals to K, absolute value of Q, divided by whatever this R is, right? We call this R, for instance, R squared. So you're going to see that E2 equals E3. Therefore, they're going to cancel each other out. So we don't have to take them into account. E2 cancels out E3. Then we are only left with 2 contributions being, well, let's call it E1 due to Q1. Let's show the direction of that guy. So E1 is going to be towards Q1 because Q1 is also negative, right? This is going to be the direction of E1. And now for the direction of the E4, let's show let's use a different color. So then Q4 is also negative, right? Here, it's negative 27 microcoulombs. Then it's going to be in the opposite direction. So this is E4. Now, let's calculate the magnitudes, because now E1 and E4, the magnitudes are not the same since charges are different, right? Q1 is different than Q4. So let's do just that on the new page. So we're calculating E1, which is K, the absolute value of Q1, R squared. Remember, our R was L over 2 times square root of 2, the hypotenuse of half of, well, 1/4 of the square, the area of the square. So then from here, R squared has to be L squared over 4. Square of square root of 2 is 2. So these are going to cancel out. What we have, L squared over 2 for our R squared. So that K magnitude of Q1 over L squared over 2 is what we have for the magnitude of E1, right? So then 8.99 times 10 to the power 9 Newton meter squared per Coulomb square. Q1, the magnitude of Q1 is 38.6. 38.6 times 10 to the power negative 6 coulombs. I did the conversion to coulombs. Then L, remember what L was? It was 0.525 meters. 0.525 meters squared divided by 2. So then we're going to see that our E1 equals to 2.52 times 10 to the power 6 newtons per coulomb. Let's calculate the magnitude of E4 the same way. So E4, that is going to be equal to K Q4 over, again, L squared over 2, right? Then Q4 is given to us as negative 27 microcoulombs. Let's just take the magnitude of that. So that is going to be 27 times 10 to the power negative 6 coulombs divided by 0.525 meters squared over 2. From here, we're going to find the magnitude of E4 to be 1.76 times 10 to the power 6 Newton per Coulomb. Now, which one is greater, right? E1 is, in magnitude-wise, E1 is greater. What does this mean? It means if E1 is greater, the overall direction of the electric field at the center point is actually towards Q1, right? Because E1 is overcoming, it's greater than E4. Let's write that. E1 is greater than E4, right? Which means E net at the center is towards Q1, the negative 38.6 microcoulomb charge that we have, and the net field then, so E net, that is going to be E1 minus E4, right, in that particular direction. So it's going to be 2.52 times 10 to the power 6 newtons per coulomb minus 1.76 times 10 to the power 6 newtons per coulomb. So that is going to be equal to 7.6 times 10 to the power of 10 to the power of 5 newtons per coulomb.